expression. And then for the other constraint, 0 equal to t minus minus, it is del minus x mu whole square. This could be equivalently written as, in a similar expression, summation over m, and from minus infinity to plus infinity, and we introduce a new symbol, Lm bar. Okay, Lm bar e to the power minus I n sigma minus. Okay. So Lm bar is summation over m, and this is beta m minus n, beta n. So when you have open string, you have only one of them, the Lm and alphas. When you have closed string, you have additionally this Lm bar, because beta here, this alpha and beta is still different for the closed string theory. Okay. So and these here, now Lm and Ln bar, these are called as the Virasoro operators.
Small technical question. Do we keep the factors of 1/2 in the definition of VLs, or do we keep them out of the definition of VLs?
You are right. I think I keep here, so I have made a mistake. I should correct it. In one of them I made a slip, or in both of them.
I think also for the bar, because it should be. Yeah.
Is that okay?
I think so.
Yes.
Didn't count all
Yes,
the
yes,
factors, but I
yes,
think
yes,
so.
yes. No, this factor of 1/2 is going to be crucial, and we will see it in a few minutes. It's going to be crucial. Okay. So I think now we can retain this, maybe just these two results, and we can almost remove everything else. Right? Sarah, is this fine?
Yeah.
Good? Okay, very good. So maybe I could mention these results here. Lm is alpha and alpha n and beta n. Okay, very good. So now we have arrived at some very important results, the so-called Virasoro operators, and they obviously also obey. And so actually, as you will see here, that they follow from these constraints t plus plus equal to 0 and t minus minus equal to 0, and actually therefore Lm and Lm bar both would be 0. So they would give us a infinite number of constraints on the theory.
You forgot the bar from the second.
Yes. Thank you. Yes. So Lm equal to 0 and Lm bar equal to 0, they would give us infinite number of constraints on our theory. And how we would cope up with that, we have to see. So now let us try to see. Before I could write down the kind of algebra they obey. So Lm and Ln, they are seen to obey m minus n, L of m plus n plus d by 12 and q minus m. I'm not deriving this, I'm just mentioning the result that they obey this algebra, which is called as Virasoro algebra. And this is for the open string, and for the closed string we have Lm bar, and m minus this, m plus n plus delta n plus n equal to 0. This is called as the Virasoro algebra. Virasoro algebra. And this term is called as the central extension term. And this guy is called as the central extension charge. So D is the central charge of the string theory, and here you see the coefficient mq minus m.
Are you sure with m minus n? M minus n? So we should have, when it is the commutator of Lm and Lm, it should be 0.
You mean here?
No, the right one. It's not 0 when n is equal to n.
When m is equal to minus n.
Yeah, but for m equal to n, it should be 0.
But the delta function is 0 then, isn't it?
No, for m equal to n, we have delta 2m and 0.
Yeah.
It could be 1 for m equal to
So m plus n
yeah,
equal to 0. This should be, yeah, so L0, yeah. So actually this m equal to 0 and m equal to plus minus 1. This is a very special class, and because for this term would drop out, the so-called central extension term would drop out, and what happens is so that L0, L plus 1 and L minus 1, they form a closed subalgebra. Okay. So, but I would not go beyond this.
Yeah,
Yes.
just a very technical question. On the right hand side, the Virasoro operators. Is this an operator equation? So do we require that the operators are the zero operator?
Not yet really, not yet really.
On the states.
No,
so
no,
we
not yet
expect-
really, not yet
Okay,
really.
oh,
So in a way, we should call that, okay, they are still classical.
Okay, so we don't have to worry about this with
No, not yet, not yet,
Requirement of
not
operators
yet,
on
not yet,
expectation values
not
of
yet,
states.
yes,
Okay.
yes, not yet. Okay, so the literature calls them classical. I somehow don't like that idea very much, because in classical we don't have actually any operators at all. So this is more technically, to be more technically correct, I would call them not normal ordered relations, because eventually we are going to introduce normal ordering. Okay, because in field theory and in string theory, everything is supposed to be normal ordered right from the beginning up to the end. Okay, so that is the idea. And okay, so I think that stands clear. Christian, is that fine?
Yeah.
Okay, good.
Yeah.
Yeah, this automatically immediately arises in the mind what is now happening. So let me remove all this again. And I thought, because the expressions for Lm and Lm bar were written, I thought I could first write this so as to complete. We have not yet gone to the normal ordering. We gradually go to normal ordering. And so from, as we have seen that L0, L plus L minus, L plus 1, L minus 1, they play a very special role in the whole thing. So let us just write down L0. L0 is 1/2, or let me take 1/2 inside. So n equal to minus infinity to plus infinity 1/2 alpha of minus n. Now let us first consider the term 1/2 alpha n alpha minus n alpha n equal to minus infinity to plus infinity. So this would be, because here the summation includes n equal to 0. So we separate it out, 1/2 alpha square plus 1/2 of n equal to 1 to infinity plus 1/2 of n equal to 1 to infinity of alpha n here you see the summation was from minus infinity to 0, I mean minus 1 minus 2 up to minus infinity, and plus 1 plus 2 plus 3 up to plus infinity, and 0 as well. So we separate it out, n equal to 0 term we separate out here, and this n equal to 1 to infinity, this is also n equal to 1 to infinity. But now let us see what happens to this term. This term I could then write as